The 12-factor app, a methodology for building software as a service apps. It's kind of a really grand statement. But don't think of it as a methodology. I wouldn't even technically classify it as a methodology because I had looked up the actual definition of the word, and it's not really a methodology. It's more like a series of sort of time-tested bits of advice. It's kind of that stem from a lot of real-world experience for effectively deploying and scaling web applications. Ultimately, this advice is going to allow you to build web apps in a really kind of ops-friendly way so that they can be deployed and scaled very reliably using conventions that aren't tied to any particular technology stack. And this is a great thing when moving into the world where microservice architecture is a thing and people want to write every single service in a completely different language for some bizarre reason. But this kind of stuff allows them to do it at least. 12-factor app stuff is old. The last time the 12-factor app website was updated was 2012. Now, it's not been abandoned. I think it's just been distilled to some really nice advice that kind of, it's not bound to any particular technology or time. It's just kind of very nice low-level advice that you can use, and it doesn't need to change. I know that change is kind of a sign of progress in our industry, even if it's really negative change that has no need, but it's done. And I think that's a sign that it's good advice. The other indication that it's good advice is that a lot of the points that are in this are already kind of codified into modern technologies. Things like Docker and Vagrant and the concept of microservice architectures and scaling up or scaling out in that way. You kind of find that this stuff is some of it may seem like common sense, but hopefully there's still a fair bit to take from it. So first, a software story. So here we have a bit of software. A team has got together. It could be a team in some large services company or some sort of startup, but they've got together and they built this bit of software, and it's got to the point where it is now a minimum viable product. So it's not just some thing that doesn't work. It actually can do something very minimally, and now they kind of need to get that to people because it's not earning any money while it's sitting there on people's laptops. So first things first, they put it somewhere. Now that could be anything from something as basic to deploying PHP scripts via FTP up to some live running production server, which is insane. Or at the other end of the kind of insane spectrum, building up a 2 gigabyte Java Enterprise war file that you hand over to this really massive ops team that deploys it across a massive WebSphere cluster around the world. One way or another, the stuff that you wrote gets out there and people use it. I'm going to assume that we have built something that people do want to use, because it would be a bit crazy if you just blindly went into these things. So there was a certain level of user research done. There was a niche need identified, something like that. But people come along and they use it. And because they use it, they pay you for it. Now it could be a subscription model, could be a one-off fee, just simple ad revenue, but one way or another, they give you money and that completes the glorious cycle. That money then goes into developing new features, improving the service or product, building new services or products, and the cycle continues on. But we have, in terms of those top two things, where people using it and people making money, we have surprisingly little control over those things. Sure, we could spend years doing a lot of detailed user research and identifying real needs, but at the end of the day, if someone else's banner is slightly more pink, then people are going to want to use that more. People are extremely fickle. There's no guarantees that you can force people to use stuff. You should never try. And as such, you can't guarantee that they're going to give you money for it. But what we do have control over is the software itself and the deployment of it. And if we can make this as efficient as possible, a bit at the bottom, then we can change a lot quicker. We can get stuff to people that they actually want to use. We can pivot, if you want to use that term, to something that actual people do want to use. So you can change your mind. You can do experiments and stuff. And this is basically, this point here is where the 12-factor app concept stuff comes into. It's effectively a way to manage the technical aspects that we have control over. It originally came from a company called Heroku, which are a platform as a service offering, a bit like Azure or App Harbor, things like that. Essentially, you push code to them, they build it and they deploy it, and your basically involvement in it is scaling up and down by twiddling knobs and paying whatever money. And it's a really nice It's a really nice way to deploy software, but it can be quite expensive in comparison to other offerings. And this still came about before things like DevOps and microservice architecture were real kind of things that people were kind of overusing. It was just work that was being done in real life, and that's how they got to the point of this advice. But there is one word I kind of want to point out here, and that is service. I think a lot of companies, especially services companies, oddly enough, tend to go into software development with the mindset of building a product rather than a service. And I know these are words and they can mean different things, but what I mean in this regard is I've done a lot of work with the UK government, and the UK government identified through the Government Digital Service, GDS, this problem in government, in that a department will engage with a really large vendor like IBM, and IBM will spend the typical kind of 6 months to a year writing a spec. They'll sign that off as a contract to say this is what we will deliver. The spec came from not any real engagement with users or identifying real user needs, but simply with higher level managers. And then maybe a year later, they will drop this product that's perfectly, it's contractually exactly the same as the spec, and people don't want to use it. You see a lot of the old citizen-facing transactional services in UK government they're pretty awful, they're pretty ugly. There's no usability brought into it, but contractually speaking, they did what they were supposed to do. So the Government Digital Service kind of turned this on its head, and as part of their digital transformation, they said, right, we're not going to do it this way. We're going to make projects very small, and we're going to embed a technical team inside a business unit of a department. So this business unit has identified a user need. They're going to use proper user research. They're going to actually talk to citizens, and they're going to build this thing inside the business, run by the business, not predicated by a big IT department saying, here's your stuff, now use it. And the difference between building of a product in this case and a service is that a service or a product is basically something you put together and you hand it over to the department or the business unit and say, there you go, sign my support contract for business as usual stuff, and they walk away. There's no concept of continuous improvement, but people's needs change, so there really should be. Any continuous improvement that goes on is usually mitigated or managed through change control, which is a ridiculously expensive, lengthy process. So you struggle to keep up, so therefore you don't maintain the product. On the service side, a service is defined as having a beginning, a middle, and an end. You run an alpha internally, you run a public beta that some select people use, and then eventually the service goes live and everyone uses it. But in each one of those stages, there's always continuous improvement. There's always a concept of we need to continually keep changing this because here are some user needs that we haven't thought of before. Here are some new things that we need to build. And they constantly iterate on that, irrespective of if things live or not. So they have to have a lot of assurances that deploying stuff to live is going to work. And I think people need to get into the mindset of building a service, because you build software completely differently. You think about things like, how are we going to decommission this in the future? How do we make changes? How do we maintain it? It may not be the same people, but pretend it is going to be you having to go back and look at that code years from now. I'm actually on a project that I left 2 years ago. I'm looking at the code. It's not bad, actually. My code's not great, but everyone else's code is quite good. It's quite refreshing whenever it's built in that mindset. So we should consider the creation of a service rather than the creation of a product. So 12-Factor App has a number of very high-level goals, and they're quite admirable goals. Okay. The first one is to minimize the time and cost for new developers joining the project. If a developer has to sit there for 2 weeks trying to get something to build on their machine or mess around with stuff they really shouldn't be messing around with, they're not delivering any value. So, get the startup time, get them to check out the code, run a script, and everything should be running, and they can start writing code, and that would be fantastic. Number 2 is to maximize portability between execution environments. So it doesn't matter if your little service that you've built is running like on this machine down here or in the cloud somewhere scaled out massively across the globe. There's no reliance, there shouldn't be any reliance on particular operating systems to an extent, or any particular system-wide packages, so that you can lift things and move them around as and when you need to. Number 3 is to enable continuous deployment for maximum agility. I think it's a very consultancy term, but essentially, you want to change, you want to make changes fast, you want to roll things back, whatever. You need to think about how you continuously deploy things without affecting users, without any downtime. And some of the concepts in here allow you to do that. And finally, scale up without changes to tooling, architecture, or practices. Having to cope with a 1 hour peak in demand on some sort of web service because somebody posted it on Reddit or Twitter or something like that. It shouldn't mean having to take down your site and make code changes or buy expensive hardware. It should be a matter of switching something on, scaling up, scaling down really quickly. And 12-factor app allows you to do that to an extent. So that was the kind of the first bit. And that was the kind of hopefully it explained like the why and what we're going to talk about. This next bit is the 12 points, hence why it's called the 12-factor app. The 12 points that it calls out that you should do. I'm not going to spend equal amounts of time on each one because some of them may be contentious, some of them may not be. Again, it's your own context, but I don't want to like spend a lot of time on some of them because we kind of cover them as they go along because they kind of inform each other. So on to the first one. Code base. One code base tracked in revision control with many deploys. This is the how you from an infrastructural side of things. This is how you define a 12-factor app. So you have a single code base. If your 12-factor app requires you to have 2 different code bases, like 2 different Git repositories checked out, it's not a 12-factor app. It's not considered a 12-factor app. If they are both services that need each other, then you effectively have a distributed system. Each one of those could be in and of itself a 12-factor app. It doesn't need to be, but for a 12-factor app to be considered a 12-factor app, it should be a single code base. Code sharing in terms of, say, you have a bunch of domain classes, shouldn't be done by checking out two code bases. That's a violation. You should use dependency management, which we'll talk about in a wee minute. So then that's what a code base is, and a code base then has many deployments. A deployment is basically a snapshot of that code built and running somewhere, developer's laptop, production. Any point in time, there are different there are different deployments. They could be different snapshots in the history of that code base, but they should be all running. And that's just in terms of getting the vocabulary right. That's what a deployment is. So dependencies, I've already kind of mentioned that you need to use dependency management. So whenever you're dealing with dependencies, you should explicitly declare them and you should isolate them. So there's 2 different kind of definitions here. The declaration is the use of a manifest file. So NuGet has a way to specify, these are the different dependencies that my application requires. These are the actual versions that at this point in time, with this snapshot of code, we know this works. You have Gem, you have Maven. Everything has every system kind of has a dependency manager now in some shape or form, apart from kind of Go, which just has really just a folder, which is a good thing, I guess. So that's the declaration. So that means that a developer can check out the code, run the dependency manager, get the actual dependencies that are known to work with this thing, and they don't have to go around and download jars or DLLs from somewhere where they may get version problems. If you ever use Tomcat, a lot of the Tomcat stuff for like database connections and stuff, you have to go and find a jar somewhere and drop it into this folder. If you get the wrong jar, like a wrong version, then code behaves differently, and it's just bizarre. You should just never do that. Take all that unnecessary thinking away and put it in a manifest where you explicitly say, we know this works. And there's the isolation side. When you build your 12-factor app or your app and you put it somewhere, you could be running maybe 30, 40 different services on the same hardware. You don't want your dependencies to potentially break other people's dependencies. You don't want some sort of global store where you drop things that are not versioned correctly and you maybe overwrite a different jar or DLL or sort of gem or whatever. You want it to. So the concept is called, in many languages, called vendoring. So whenever you bundle your dependencies in with your application, you have vendored all these dependencies. They're usually in a subfolder that go along with your application, and they're perfectly isolated from every other service that's running. So you can have multiple versions of the same thing, the same dependency across your server, and that's not a problem. The 12-factor app stuff even goes so far to say that if you use things like shell out to things like curl or wget, they should also be vendored. So you should never rely on the existence of system-wide packages, because one, each system has a slightly different implementation of it, and there's different versions, and you're making certain assumptions that may break. You should, as best as possible, put these things in the same way you have your normal dependencies for your application. External ones should be vendored as well. And then we have config. So this one is a thing that I like, but I think it's worded slightly incorrectly. So config, store config in the environment. I think what it should have said is don't store config in your code base alongside your application. When I say config, I mean things like credentials. You should never be checking unhashed sort of passwords into your code or anything. That's a bit crazy. But even from another perspective, things like credentials, URLs for other endpoints, you're deploying these things to different environments, and they all have different configuration. Once you move into the world of putting configuration in your code base alongside your code, you're probably going to end up creating a dev.properties, test.properties, production.properties. And I have a really terrible story related to this. It was a Java project, and I think it was throwing stuff into Mongo, but the application, what it had to do was, before it sent it over the wire to Mongo and stored it in Mongo, it had to actually encrypt the data. Now, that made testing and development a pain in the ass, so there was a configuration flag put in to encrypt equals true or false. In dev, it was false. In test, it was false. In production, it was true. This existed across the 3 different files, and the default was the dev stuff, as it usually is, and that was set to, obviously, don't encrypt. Somebody slightly refactored the deployment pipelines, thinking they'd tidy things up, left out the little flag to say what environment to use, and about 3 or 4 weeks later, we discovered that we were actually throwing unencrypted data into, it was actually pre-production, so we didn't quite get to production, which is good, because it would have been an extremely expensive problem. But what if we had basically put a placeholder in our configuration for saying, pull this information from the environment? Then when we provision our environments, at that point in time, we say, yes, encrypt it or don't encrypt it. So we have we basically have a consistent way of doing it across environments. Nothing has to change. We have this one file or this one mechanism for pulling out configuration, irrespective of the environment that we're in. And I said that this bit of text was kind of round the wrong way, because I think it's a good minimal solution to store things in the environment as environment variables and inject them in. But I also think there's plenty of really solid tools out now for doing things like service discovery and configuration management, so things like console, etc, surf. And when an app boots up, it can register itself with service discovery and say, also give me all my configuration, and it grabs the configuration based on that deployment. So there's some sort of way to identify that deployment, and the configuration is loaded that way. So you don't have to necessarily inject it in the environment, but that's a nice starter for 10. So now we have a little 12-factor app running. It obviously probably needs to do something externally. Maybe it needs to store some stuff in the database or a file share. It probably needs to talk to the other APIs. So rather than hard code any, you don't need to worry about that text. It's just, they're just addresses. Rather than put any sort of concrete implementation details into your code around backend resources like databases and stuff, you make them as attached resources, and I mean resources in terms of how you would talk about it in REST, something that ultimately is addressable and you can send commands in some shape or form to. So you have this address that you put into configuration, so in your environment or through some sort of configuration management. And that means that whenever you want to do things like swap them out, it's a matter of changing the URL. And that is really, really nice, because it means you have no distinction between something that's running locally in that machine or something that's running, across the world somewhere else. And should you have to swap them out for some, slightly bigger database or something bizarre like that, it's a simple matter of changing that URL. You don't have to reconfigure code or anything. Just change the URL and, maybe restart the app or whatever, and you're good to go. So that makes them infinitely composable. And infinitely configurable. Then we have the concept of the build phase and the run phase. And a lot of people still seem to get this wrong. Do it in a weird way that's kind of a lot more costly. 12-factor app asks you strictly separate both stages. So what is the build stage? The build stage is basically taking a code base and converting it to something that is executable. So a commit you commit and push something and get for your code base. Jenkins will come along and it'll basically run all the tests, check it out, run all the tests, and then build it. And that'll give you some sort of artifact that you can execute somewhere. Now, that's typically initiated by a developer. While Jenkins may build it and stuff, ultimately it's a developer action that said, right, go ahead and produce this artifact. A release then is essentially bringing together any environment-specific configuration and that build, and that gives you kind of a release. These things are usually time-stamped, or they use a Git ID or something like that, and you have a release. The run stage is then running that in an execution environment. So everything that's been done, bundled together, and simple matter of just running it. The key thing here is the running of something in an environment is usually initiated by or performed by a machine rather than a developer. So it's at the other end of the deployment pipeline. It's went through various stages of verification, usually in an automatic way, and it's now the machine is running it. So what you want to do is you want to minimize the amount of moving parts. You don't want to have to unzip a file, move it somewhere else, delete other files, stop a bunch of services, restart them, move files around. You want it to be as simple as possible. Just like drop this executable thing there and say, right, go ahead and run it. That way, you don't get a lot of problems with your actual deployment. So there was something else I wanted to say there, and I've forgotten it. Oh yes. So if you don't separate the build and run phase, usually what that means is going into an environment, checking out the code base, even production environment. I've done it myself on quite small projects. It's kind of a quick win, but it's a terrible thing. Checking it out at a certain point in time, and then doing a run, resolving all the dependencies, and basically running it in situ. The problem with that is it has to resolve the dependencies in every single environment. And this is done at different times, and a lot of dependency managers you can quite sneakily, and even in the global scope of things, you can actually sneak in updated versions. So if you're working maybe with snapshot versions, which you probably shouldn't be in production, but let's say you are, let's pretend people aren't completely malicious. Those are new versions that are deployed. The version number doesn't change, but the behavior may change. And so what works in one environment doesn't necessarily work in another. But if you produce a build at the start, that's with a known good set of dependencies, and that can be pushed around environments without having to worry about that overhead. Also, production environments probably don't have access, they're considered to be more locked down, so they don't have access to things like npms, registry, or anything like that. So that's that bit. Now we're kind of moving on to the way that you run these things in an environment. So run 12-factor apps. They treat processes as first-class citizens. Okay, so an app is essentially one or more stateless processes, and the stateless thing is key here. I don't know, yeah, you can see the wee dotted line. So that little black dotted line is effectively your 12-factor app. There's 3 processes running. There's one web process, and there's 2 sort of background worker processes. These things can be anything from a simple Python script that just runs and just sits there, or something like this, a more sophisticated one where you have background workers and stuff like that. That process formation there is your 12-factor app. They share nothing directly, and that's key. You never rely on the existence of other processes. They run in an isolated way, and they should be stateless. So they shouldn't be passing long-lived state around. If you do need to store things like state, or you do need to communicate with the other processes, you do it through things like attached resources, so a queue or a database. That means things like sticky sessions, which are just an awful idea. They're gone. Everything should be stateless, and everything should be built with that concept in mind. So everything should be nicely isolated, and you're relying on the operating system to manage these processes, and that's a great thing, because operating systems like Linux and Unix, those lower level service managers, that's kind of what they were built for. So pushing more things down to the operating system is kind of a nice idea, because they're very mature tools. So we've got these services. How do they talk to each other? Well, they talk to each other. We kind of alluded to this in the attached resources stuff, but they talk to each other via port binding. So a 12-factor app is completely self-contained. So it doesn't rely on, for example, the existence of a web server. It doesn't make an assumption that a web server is there like Tomcat or IIS. It basically embeds its own web server, and it binds that web server to a port. It could be a hard-coded port of like 9,000, or if you wanted, manage scaling up properly on the same machine. It'd be some sort of ephemeral port that finds the next available in the range, binds to that, registers some service discovery thing, go, this is me, and those things can be load balanced then. But that kind of explains why stateless is good, because if you're load balancing and you're not using things like sticky sessions, then load balancing is significantly more easier. The routing of it is just you configure it whatever way you want. So that means that an app has expanded or exported some sort of port, and other apps can then use that as an attached resource. So you want to scale, obviously, to cope with certain demands. You want to scale up and down, manage your costs. And 12-factor apps scale out via the process model. So we have this ability to control processes. They're first-class citizens. So it makes horizontal scaling much easier. You basically, you want to, if you have a spike in demand for the background worker stuff, it's a simple matter of, it can be done automatically or manually, of starting up a bunch of new processes around the worker stuff. So the control is a lot more fine-grained because you've broken out the different parts of it, different parts of the actual app itself into multiple processes. And then whenever you're done, you want to scale down, you just basically turn that dial down or kill off a bunch of processes, and you're kind of paying less. All this stuff is done, again, with the service management capabilities of the operating system. And while they kind of vary across different flavors of the operating systems, they're still all really good in comparison to putting something in like WebSphere and having WebSphere manage this like memory stuff internally and stop and start things. It's a nicer model, and it scales a lot better, especially on the horizontal axis. Yeah, X. Okay, so we have processes, and they scale up and down unpredictably, and they're running on really low-cost hardware usually, and somewhere in the cloud probably. So they are going to die one way or another. So when you build services or 12-factor apps or whatever you want to call it, you need to maximize the robustness. So one, you need to make sure that the things start up quickly. If you have a 25-minute peak for a web service every day, you want to basically scale up really quickly. And if you have a service that takes 3 or 4 minutes to spin up a brand new process, then you kind of have to do it well in advance, and you have to be able to predict things, which you can't necessarily do. But the quicker you can start things up, the quicker you can cope with that demand. Now, that means that things like Java technologies and stuff are actually, they have quite, like Scala or Clojure, they have quite slow startup times, and they're a bit kind of, in comparison to things like C and Go and Rust and things like that actually compile natively. Then there's a bit of a contention there in terms of different parts of your system could maybe be built in different things to cope with the need for faster startup times. But then at the other end of the spectrum, you have the kind of the shutdown stuff. You can be manually scaling up and scaling down, and that basically relies on the operating system to kill processes. So they have to be able to shut down gracefully. You don't want to kill a process that, while it's like going through some sort of mid-transaction thing, and then put your system in a complete state of unpredictable behavior. So things like backing queues and stuff are usually quite good. A worker process takes something off the queue, marks it as in process or pending, does the work. Once that's done, it says it's done, and it takes it off the queue. Otherwise, if that then dies, then it can restart the work again, and it can pick up where it left off. We've got to also assume that data centers on this low-cost hardware are probably going to explode or go on fire at some point in time. So we have to be also ready for kind of sudden death of our processes. But building disposability into the development of your application means that you can kind of do faster deploys more reliably, because these things are going down or coming up, and therefore you build fast startup times and graceful shutdown into it, which means you can do more deploys, you can be more confident about those deploys, and then you can build in at higher levels things like rolling deploys, where you do separate your deployment into different legs, so you have absolutely almost zero downtime. Then there's the dev prod parity, and I think most people kind of will say, yeah, this is a really good thing. Our tools are certainly moving in this direction. But it's not, a lot of people say it's a really good idea, but may not have it in real life, which is a shame. Keep development and staging any environments as identical to production as possible. This is kind of something I was involved with before. I dropped into this company. I was doing a bit of consulting with them, and their development machines were all OS X based. They used Apache that was built in the standard Apache stuff, and they used MySQL as a database for running the apps that they were deploying. Then in the stage environment, for some reason, somebody decided to move to MariaDB. Don't know why. Maybe they kind of wanted, they were partially migrating everything to MariaDB. I'm not sure. They used Apache, but then they didn't want to pay for a Red Hat license for staging, so they used CentOS, which is somewhat equivalent. And then in production, they used a massive Oracle database. They used Nginx for some reason, and they used Red Hat. What that meant was, whenever you did a deployment, and these deployments in this place took a long time, we are talking potentially 3-4 months to get like a single line of code into production, going through all these processes. Then the day came where they would manually deploy to production, and they would run the thing, and it would run for 2 or 3 days, and then all of a sudden, something would fail, and something would consistently fail. And it took maybe 2 or 3 weeks to get logs out of production because the logging was pretty awful, and you had to go through approval boards and stuff. Do you understand why this thing is failing? It turned out that it was something to do with the way whenever you do a batch insert in Oracle, it doesn't return all the IDs, whereas things like MySQL does. So it was a slightly different behavior in these kind of at the database level that was causing this failure. And it took forever to find out. Now, if we had a Red Hat Nginx Oracle virtual machine running on our dev environment, we could have reduced that time to actually deploy that thing and fix that bug. When you move to things like continuous deployment, the delta between dev and prod needs to be almost zero, or as zero as possible. So that kind of informs a lot of technology decisions as well. So, go with a big Oracle server if you're willing to pay for licenses for every single machine that you have. So there may be open source alternatives. But that's a conversation for another time. And this is one of my favorites. I think it's probably to do with the fact that I have spent a fair few years working in Java JVM world that seem to have about 3,000 different ways to actually implement logging. Log4j, log4j2, SLF for J, SLF for J2, log back, loggy thing, I don't know. But they're ultimately all kind of XML based things, and to get them to work you have to include various jars, and it's not really well documented. The problem with this is you're not really treating the logs as well as they should be. I don't think developers treat or use logs as a way to identify problems that they haven't even thought of. I don't think people think a lot about their design of a logging, and I think they really should. For one, most operating systems have a fantastic set of tools. So you've got standard out and standard error. So you do a print line to one of those. It goes into the operating system, and basically there's a lot of operating system tooling that allows you to do things like, so syslog you can use to aggregate all these logs. All these streams going into the really mature operating system management capabilities. Then you have things like, you can then pipe that out to a file. You can then use log rotate, which is built into most operating systems to rotate the logs, instead of having to rely on the existence of something like configuration in XML that, pipe it out to this file, rotate it every 2 days. If that's configured wrongly, it doesn't rotate. There are really nice, simple tools that don't really care about what technology you're running. Right to these lovely 2 streams, standard out and standard error. Use syslog, use log rotate. You can then pump them into files if you want to. You can then pump them into things like logstash, filter them wherever you want. You do a lot of analysis, but even with simple things like grep and sed and awk, rather than having to rely on this crazy technology that they keep trying to standardize and end up with another standard each time. And finally, admin processes. So every single application has some sort of series of admin tasks that it needs to do. By that I mean, say, DB migrate in Rails. So you want to run database migrations when you deploy something to an environment. Or you have things like, I want to clear some sort of cache. I don't know. But there's a bunch of admin tasks, and 12-factor app says that these should be run as tasks on the one-off process on the actual execution environments that the deployment is running. So you run against the release in the same environment. That reduces the risk of slightly different behavior between the script and the application. And to this end, the 12-factor app stuff strongly favors languages or ecosystems that have a REPL. So things like Ruby or Clojure or Scala, just anything that has a REPL that you can connect to. I know it sounds a bit scary that you mean you can basically just REPL under production. It's fine. There are ways to reduce the risk around that, but yes, why not? Think about how you do that. Don't just have this like port open, whitelist things or whatever. But being able to go on to any production environment, or any environment as something is running and performing one-off tasks in that same environment means that you have a predictable way to do things. Something as simple as SSH onto the box, running a one-off script, and walking away. Nothing that is formed as part of the actual application, but they could exist within the code base. There could be like a scripts folder that also gets deployed with your app. You go in and you run that on that actual instance. And if you want to know more, as I said, it hasn't been updated in a while, but 12factor.net is the original kind of source material that I took this from. And it has a lot more diagrams. It has a lot more meaningful diagrams rather than the ones I threw together. It has a lot more text and a lot more examples of how you do these things. I think you should check it out. And that's me. Does anybody have any questions or anything? Or?
Yes, I have a question.
Yes.
You say that the app should have one code base.
Yes.
Does that mean, let's say I have some idea for an app and I have different branches which are basically kind of different approaches to the implementation. Does a branch count as like a different code base?
So you mean in terms of the code base, you have multiple branches. Do they represent, is that breaking the rules of the 12-factor app? No. Especially if you think of Git. Git is linear. There isn't such a thing as a branch as such. It's an idea. So it's a snapshot of code at any point in time. I wouldn't take a lot of this particularly literally, especially the code base stuff, because if you think about how Google, who use a lot of kind of microservices and stuff, their code base is a single code base. The entirety of Google you check out once. All the code exists, and they share via folders and things. So I mean that kind of is not really a 12-factor app. Kind of breaks that rule. It's not that they really care that they're breaking the rules of the 12-factor app, but no, it wouldn't. I wouldn't really consider it a violation of it. If you can deploy by simply pushing a bit of code to somewhere, like a single code base, and everything else is resolved by dependencies, no, there's no rule breaking there as such.
And how does having a single code base work with like really, really big enterprise applications?
So.
It's like really insane to like have the entire code base on a single machine.
Do you mean in terms of running it?
Running and compiling.
Yeah. Okay. So I mean, so how I guess the question is, how does the code base, single code base stuff work with very large applications? So a 12-factor app doesn't need to be like a service-based, microservice-based, whatever you want to call it, application of a series of 12-factor apps. It could be a massive monolith. It could be just a big, huge Rails thing. It's the process around how that's deployed. And the rule is simply have it in a single code base, have a convention for how that's built. And if you're building a single monolith, then that's fine. If you're producing multiple artifacts from that code base, multiple executable ones, so you have 7 different services from a code base, that I would assume would be a violation because there's no consistent way to say, check out that code, run it, here's a single output. So it's one to many, it's not a many to many around a code base and deploys. Okay, does that make sense? Okay. Anything else? Nope. Cool, thank you.